looks more like a pterodactyl wing. That is by far the best example of that process I've seen anywhere. Yeah, it's one of those optical illusions again. To me, it doesn't look anywhere near 38 feet above me. Yeah, I wouldn't want one of those
Hi, Katie.
if I.
Brandy.
Yeah.
Like a cinnamon stick or something.
Looks a lot like this.
So 2 words of caution over here at the entrance. Right above me, I have this low, precarious-looking rock. Hasn't moved. But to be safe, don't move.
Yeah.
Also, first 3 steps coming in here, well, first 3 feet, test your footing.
Okay.
This is natural stacking of the rock. It can conceivably shift, so just be aware.
Watch the rock on the head. Oh.
178 to.
It's the most likely mineral that you're going to find in lavas.
Gypsum, okay.
Yeah. We do get some calcite too, and sometimes it looks the same, but you need ultraviolet to actually identify it. The calcite will glow.
Okay.
The gypsum does not. But yeah, it's a very soft mineral, and the way it gets here is living in a rainforest, we get a lot of rain. What you may not realize is that the rock is like a sponge. So as the rainwater percolates through the sponge, it dissolves some of the softer minerals like the gypsum. And when it reaches a place where the water can evaporate, it leaves behind the minerals which form crystals. And that's how these get here. But so you know, approximately 6 years ago, the entire bottom of the rock was covered with crystals, with the biggest being where there are none now. At that point in time, we had a man in here who did not speak English. He reached out and wiped them off. In less than a second, 500 years worth of crystal growth was gone. I will point out things like this as we go along, so you know I'm not giving you a line of BS when asked, don't touch. Proteins are carried here in some form by the percolating water. So technically speaking, we could call these stalactites. But it's a gray area as far as the term goes because these coatings are almost certainly microbial. So they're alive.
Wow.
The last thing here is the roots hanging down. These are the roots of the Ohia trees. I'm sure you're well aware the Ohia is the predominant tree in the forest and it's one of barren lava and red fuzzy flowers. But this is why the Ohia, no other plant that I know of can go through the pores this extensively. And because of that, the Ohia can tap into nutrients and water sources other plants can't access. And that allows it to grow in barren lava. But it also means that it's a major contributor to soil in islands. As it sheds its leaves, they decay, that produces soil. Without the Ohia starting this process, Hawaii would be pretty barren. Probably nothing more than grasslands. So very important plants. There should be a yellow ribbon on your right, to the right of the ladder, to say don't cross it.
Yeah.
But I've had problems with somebody coming in through another entrance. They keep taking it. Jeez. So I get tired of replacing it. So you're getting onto the ladder from your left.
Okay.
The other thing is there's 2 ladders here, small platform in between. I recommend when you get to the platform, grab the second ladder before you let go of the first. That too is for safety.
It does dive down.
Anyone afraid of heights?
Yeah.
All right, well, I got good news for you. This is a cave. You're not actually dealing with height, only depth.
That's right.
Ah.
Well, I climbed up the ladder at South Point yesterday, so.
Training.
Fairly similar. I wish the one at South Point was like this one. He was jumping off the cliff. We were
Oh,
doing
look
some
at that.
snorkeling.
Upper passages are short, but there's a lot of them. Add everything together, the latest surveyed length of the cave, 42.5 miles, which makes this undisputedly the longest known continuous lava tube in the world, and about the 33rd longest cave in the world last time I checked the standings. So some pretty impressive credentials, considering we're in the middle of it. Wouldn't it be nice if the piece of property I bought on the Big Island had an entrance to the lava tube?
Oh, no, you didn't.
A really big one.
Oh, you kidding.
Never thought about it again.
Dreams do come true.
I like, as I mentioned earlier, I like this area because it's forested acreage. I could afford it near the national park. So I put in a bid on a piece of property. They said, go away. The bid's too low. Tried another one, same thing happens. Tried this one, they countered $2,000 over what I had offered. I came up $500. We took it. Couldn't be easier. And then many years later, we find out we have an entrance to a lava tube, a really big one that you can give tours in. So be careful what you ask for. It better be what you want, because you might just get it. Not get you. The gate gets anybody that's claustrophobic. By the time you're at the double ladder, it's dark. And the double ladder itself weeds out anyone that's deathly afraid of heights, depth, or ladder.
Oh, wow. Okay. So that's the whole gamut of
Getting down here.
yeah, getting somebody who truly wants to be here.
Yeah, if you make it to the main passage, you're usually good.
Right on.
Yeah, very few exceptions.
Yeah, people turn around.
Occasionally, somebody will. These tracks are left behind by an organism called cave slime. And the slime migrates, leaving behind tracks which you can think of as being similar to slug trails. But that's one indicator of life. Another indicator is anywhere the white is not solid, if you look closely, you'll see fine lines in it.
Oh, sure.
The pattern produced by those lines is said to be almost always associated with life. So most, if not all, the white on the wall is alive.
Like this.
Yeah, there's a lot of things that are happening in here. And quite honestly, when it comes to textures like that, yeah, your guess is as good as mine. Because there's a lot of different possibilities.
Well, it looks like this piece would have been it's solidified and then got broken into pieces and then got swept up with this other flowing stuff, and looks like the whole top was like that.
You know, basically paying attention to the width of the passage. And on such and such a slope, a specific volume is going to occupy a specific range of widths.
Okay.
And once you have an idea as to what the volume was coming through here, and if accidental, somebody tripped, put out their hands to brace themselves. But if you can imagine touching the walls with bare hands, you could also deposit oils off your fingers. We don't know how long the oils will last. There's a man in California that's been trying to find out how long fingerprints last on various surfaces. I'm told 25 to 30 years ago, he put a fingerprint on the outside of his kitchen window.
Wow.
And it's still there today.
Oh, wow.
So fingerprints can last a long time.
That's incredible. Never even thought about that.
I didn't either, but I learn a lot of things from visitors. Okay, you wanted to see some cave creatures. The top two are cave moths. Same species, different varieties. The brown variety is said to be able to live its entire life in the cave. The checkerboard-looking one flies in and out. But notice it's on a cocoon composed of chewed-up roots. It's an adaptation of the larva to chew up the roots, spin it with a little bit of silk, so it doesn't have to produce as much silk. That's important because silk production requires food. Food is scarce. So that's how it's adapted. In the middle there we have a moth fly. Moth flies are not frequent visitors to caves, but I was told that the larvae eat bacteria. So it's conceivably possible if this were a female, she might have come into the cave to lay eggs into something like this on the wall. We just don't know. The most commonly spotted creatures are cave crickets. There's multiple species living here on the Big Island. To the best of my knowledge, these are the same species pictured. The one on the right is a male. It's overexposed, but I chose that photo because you can see the length of the remaining antenna. The antenna can be up to 5 or 6 times the body length. Crickets need the extended reach to find food. It's far easier to move the antennas around than it is to walk that area. On the left, female, proper exposure. Chose that photo because you can see through the body to some extent. So they are fairly transparent. And you can tell it's a female because of the ovipositor. the extra appendage in the back and the middle, which does get longer as the female gets older. The maximum size of this species of cricket, 3/8 of an inch.
Oh, wow.
More typically, they look like grains of rice with legs. We have predators. This is a centipede. This is what's called a pseudo-centipede. Pseudo-centipedes are non-venomous and they have fewer legs. But this one was found on a pool of water posing nicely. The centipede has an interesting hunting technique. It will actually take a couple steps forward and start swinging its head from side to side, sticking it into any cavity or crevice available. And apparently that works for it. In the middle is the small-eyed, big-eyed blind cave spider. It's a wolf spider, so it's a hunter. Grows to a body length about the size of the book.
Yeah. Really?
No, just joking.
I was like, wait,
Wait.
can I
What?
get out? Can I go
About
home now?
3/4 of an inch is the biggest I've seen of the body.
Okay.
You have to excuse me, I spent a lot of time in the underground. But the spider has a couple interesting techniques that it uses to hunt. One of which is it will use a single strand of silk like a tripwire. The other of which is, I'm told the hairs on its legs are so fine it can pick up the air movement of its prey. So imagine feeling your limbs tingle and thinking dinner. On the bottom is a pincher bug. On the surface they're black. They grow to about 3/4 of an inch in this area that I've seen. This was a little over an inch long. Now they are hunters and scavengers, and apparently this one found a great place to eat. We have plant hoppers that like to live on the roots and suck the sap. If there's someplace where they could fall off, they build a cocoon around themselves. That helps hold them on the roots. But notice the tail at the bottom. The tail is wax. The idea seems to be if a predator chases it down, it gets a mouthful of wax. So the plant hopper has a better chance of survival. Recognize this one? They're usually gray, like to roll up in balls.
Oh, yeah.
Believe it or not, this one was a little bit smaller than pictured. It was massive. It was also long dead. This is the exoskeleton. That brings up a really good question. Is there a cave-adapted variety? And apparently there is, but it's much, much smaller, and I've never seen it.
No.
In the middle, we have a springtail. Actual size of this was like a speck of dust. Not a great photo, but it was on a pool of water eating organic matter that collected there. And I've seen probably about 4 species of springtails in the cave. And then finally, millipedes. The one on the right came in from outside. We know that because of the pigmentation, it was lost. But its cousin has adapted and lost the pigmentation. And that's the second easiest to spot creature down here. These will grow to a maximum length of about 1.5 inches, typically shorter, but they look like pieces of string.
How common are they? How often do you see one of those millipedes?
It's sporadic. We did have a really good day earlier this past week. It's called a dribble spire. It's nothing more than the last bit of lava. Okay on information.
Yeah.
Yeah.
Funny, I'm trying to process it all.
Well, if at any point I overwhelm you with information, please let me know. I can't see the glaze overlook in the dark. Are you all aware of how these form?
I am.
Pushes up on itself.
Yeah, basically because the center of the flow is moving faster, the skin will buckle into an arch and then fold over on itself, giving you ropes. But what's important here is the fact that the arch itself, think of it as a big arrow pointing in the direction of the flow. You'll need to know that when I show you anomalies. But the other thing here is comes together with its fellow slime and migrates as a colony, if it's cellular slime, or as a single-celled organism with thousands of nuclei, if it's true slime. But it migrates looking for new food sources. And later when it comes time to reproduce, the whole colony or this blob comes together and forms what's called a fruiting stalk, which is like a mushroom except there's no cap.
Oh.
And from the top of those fruiting stalks, there would be a few cells or nuclei that start producing the new spores that start the life cycle over again. So the little bumps that you were looking at, they're the crack down the middle, collapsed. We know it happened that way because if you look in the crack towards the bottom of the slab where my light's wiggling down there, you can see the rock was actually stretched like taffy. You see the stretches?
Yeah.
Once you've spotted them, you'll find them all through here. But it's the same kind of stretching you get on the surface of an ʻAilāʻau flow. And those are called springs, just like in a river.
Wow.
Further evidence of that comes from this reddish brown lava. But promised you an anomaly. Here we have one. Notice a nice big plate in the floor. Within the plate we have the hoi arches. And which way are they pointing?
That way.
Exactly. Gold star. This did not form here. This
Oh,
formed
wow.
up the tube.
Floated down and
Yeah, initially it was oriented downslope. The levels in the tube either fluctuated and sheared it off, or rocks fell around the outside, breaking up the crust. But it rafted along, and as it rafted, it spun. And you can see the same thing happening on the surface of channels topside. It's been filmed many times.
just the right condition.
Cave. They've only shown up since. The first person to notice them, her name is Judy. Her husband promptly named them Judy's freckles. But in the center of each freckle, there's a hole or a crack. The holes in the small cracks are a result of foot traffic. Walk across the glassy surface, you break tiny holes in it. It's then believed that we're bringing in the cave on our bodies a microbe. The dripping water takes it underneath the surface where it finds everything it needs to survive. The color suggests iron-fixing bacteria. So it oxidizes the iron, uses the chemical reaction to survive. Now occasionally you'll find freckles on the wall, but they're never so high up that someone couldn't have touched. So it's a good indication we are the culprits. Just follow the bouncing lights. Singing is optional.
No.
Consistently paint like this. Tell everyone you're going through the lava tube effect. The other thing you'll notice here is if you look in this band of rock very closely and above, you'll notice that the rock sparkles back at you. Each of the sparkles is a magnesiferrite crystal. A professor from Caltech took a sample, scanned it under an electron microscope, sent me a photo. I don't know if you noticed this earlier, but I'll pull it out again. And by the way, don't share if you know why. Unfortunately, English is the only language where that word first found that way.
How fitting. Yeah, that's a cool straw.
Yeah, they come in just about into this case. Was moving slower. I'm sorry, moving faster. It was faster on the outside of the bin, in this case. So as you're getting closer to the inside wall, the flow speed decreases. Then under the right circumstances, the flow out here where my light is overtakes the flow at the wall, creating an eddy. And the eddy erodes the dimple called a stalagmite. But you can find these not only in caves, but in riverbanks, at the beach if you have a sandy bottom just offshore, and sand dunes behind obstructions. Okay, can you all see the straw now?
Yeah.
Notice the concentric rings on the shaft. As each drop emerged from the wall, it deposited a small ring of rock around its base before dripping off. The next drop adds a ring to the bottom of the first ring, and then it drips off. So over time, the rings stack downward until you get a straw. This is exactly how limestone straws form, except in limestone, the rings are microscopic.
You could probably almost count them and they'd almost match up.
Yeah,
Those
use
balls are
a...
down here.
So I looked around. There's a hole here. Some smaller ones right through here. But not enough to explain this. Because this is on a crack, we know there's organic matter brought down to dripping water. Included it must be biological. A sample was taken. It was found that the rings are like mineral deposits. The general consensus among biologists had come later. This is probably a mineral-fixing bacteria. But it occurred to me at some point that the purpose of the rings might be to slow the water. By slowing the water, an organism attached to a ring would eat more efficiently than its neighbors. So it could be an adaptation. It is, though, the strangest organism we have found in the cave so far.
Only in this area or different areas?
There's 3 patches of it here. I think there's some up here. You have to look at just the right angle because
Yeah.
there's some slime trails, slime,
Oh yeah.
more lava sickles. As I mentioned before, the levels rise, coat the ceiling. When the levels drop, you get drips. The next time the ceiling is coated, you get drips on the drips. It's like dipping a candle in wax. You get layer after layer after layer. And I'm just getting out of the way so you can look. so the Vando exposed a nice cross section there, so you can see the rings clearly.
That's the tip of another one in the middle there.
Yes. There we go. Oh. Okay, so these are the more typical type of straws that you'll find. Notice they have segments. Each segment's a drop of lava that has elongated and begun to freeze in place. The next drop squeezes out of the weakest point of the first drop. The process repeats. Weird shapes, as I mentioned, are caused by air currents. So picture hot gases surrounding these and applying a pressure. Or the gas can actually help to oxidize one side more quickly than the other. And oxidation would raise the melting temperature on that side, causing solidification. So it leaks out the other side. But straws are very versatile. If you can imagine a real process happening in a little tube, you can find examples of that process in straws.
Here's a good example of those lines with the.
Yeah, that's our next point of interest. Now you might recognize the pattern as the capillary action of water over a surface. The skin of a citrus fruit. Fungi roots growing outward way. You can even find that pattern in water if you look at water with infrared. So it shows up throughout nature and to help it survive on the barren lava. Crafters from Canada took one look at this knob. They said that they see the same thing in rivers. On the inside of bends, where you have an eddy. And in the river, the eddy would erode away all the rock back here, leaving the knob. But in lava, it's more probable that once the eddy becomes established, because there's little to no current in the center, lava sticks here and forms this from the top down. Later, an engineer is looking at this and at that. She says they have to be related. That leads us back to this. Until my niece was in here. My niece was short. This rib was just to protect her head, so she walked underneath. She found something that other people had noticed, but she knew what she was looking at. She pointed right up here where my shadow's wiggling. Can you see that little nub? She said, "Hey, look, it's the tip of a lava sickle." We have a couple more here.
Yeah.
A far more obvious one right there. But because she was so certain about what she was looking at, my brain started to function. And I realized at that moment, anything below that level was added. So we had an eddy,
Oh.
creating a knob.
Yeah.
But that leaves one good question. What are the lava sickles attached to? 3 possibilities here. 1, sagging ceiling. 2, a rock that got stuck there. Or 3, the bottom of a knob created by an earlier eddy. If I had to guess, I'd go with the latter, but I have no proof. But you can see how you can get the right answers from unexpected sources. Yeah. But it took me 20 years to realize it should be fairly easy to prove. Nature hides things in plain sight. So if you have to explain those little mistakes, you need a complex theory. Which tends to screw everything up. So yeah, my biggest challenge to figure this stuff out was bringing my thinking back down to grade school level. Yep. Tell me about it.
So many variables with each different flow. You get different outputs or.
Yeah, I mean, it can be the flow volume, it can be the time frame, process, and time lapse. This long V shape would actually appear to zip itself closed, starting at the vent, working its way down slope. And I have seen this in time lapse. It looks like you're zipping up a jacket. It's that smooth. But you also have to be aware the channels are not uniform width. 4 surface flows. But there's only 2 surface flows there. The way you can tell is by looking at the bubbles. The top of the flow cools quickly in contact with the air. The bubbles do not have time to come out of solution, they remain small. The bottom of the flow cools even faster, so the bubbles are even smaller. The center stays hot longer, the bubbles collect in the middle. Those 2 layers are one pohoihoi flow. Same thing here. Small bubbles, bigger, small. One pohoi flow.
Makes sense.
But the other thing that you have to realize is that when the upper flow covers the lower flow, this upper surface is cooling so quickly it cannot conform to every irregularity in the old surface. That can leave gaps between the layers. All that happened long before this eruption. So time passes, there's a new eruption, lava's flowing over the surface, creating a tube as it heads towards the coast. And as soon as it makes it to the coast, the lava has someplace to drain to. That allows the flow speed in the tube to pick up, which begins the erosion process. But during the whole process of approaching the coast and then later downcutting, heat is radiating into the surrounding rock. So everything's getting hot, including the cavities. So by the time the lava eroded down this far, these cavities are hot enough that when lava was injected in there, it remained molten. And it stayed there until the levels dropped sufficiently that the... this is the one place where we do have some flowing water.
Yeah.
Okay, this is thin. Picture the crinkles on the ceiling. Imagine them then getting recoated. The drips are going to come from the crinkles.
Sure.
That's one possibility. Another possibility is think about old paint peeling off and then getting recoated. This could be a combination of both, or one or the other, or possibly none of the above. But for obvious reasons, we call this the chocolate lava sickle ceiling. And this is the best patch of these that I've seen anywhere in the cave. And I'm getting out of the way so you can look. Sorry. Come back.
Look at that thing's like thin. It's like you can see through it.
And you add water to it, and it will produce 6 FeOOH3. The highest ceiling on this end of the canyon is over here, 32 feet. So they basically found the narrowest place, busted through and reconnected it. Yeah, it's one of those optical illusions again. To me, it doesn't look anywhere near 38 feet above me. We also have this hole back here. And when I first saw this, the wall floated in place. The whole process probably took about 30 seconds. Wow. But look at the size of the fillet. Compare that to the size of the passage we just walked through. What do you think could have happened if it had continued? The closer you look, the more detail you will see. It's incredibly intricate. No sidelining, does that help?
Sure.
As they were forming, the lava levels were dropping in stages. They drop a little bit, stabilize, drop a little bit more, stabilize longer. That's how you get the upside down mushroom shapes. The bottom of these are scoured with flow lines, but what truly makes the wow formation unique is the fact that you have those lava blades that you can see right between them into that cavity in the back. What's typical of knobs with lava blades is what's on the opposite side of the passage as you look back. Those we find throughout the cave, but there is only one wow formation.
And it
And it's a
fell.
mongoose on the floor there that you were looking at.
Yeah.
Yeah, when it was still pretty hot in here.
Mm-hmm.
When the crust might have been over a year ago now. But he wanted to take some samples of the water to see what was in it. And I'm thinking it's just water, but we're trying to get the stuff off, and it really wasn't coming. So I thought, well, maybe my tweezers would help. So I carried tweezers to pick up trash off the floor. So I got them out, and essentially, I'm gonna taste it.
Salt?
No. Essentially, that tiny, tiny little drop, but the brown stuff is from whatever ate the pig. You can also see that some of these bones are sparkly. Now, these sparkles could be aragonite, which is a form of calcium carbonate. It could also be some form of calcium phosphate crystal because the bones are said to be calcium phosphate. But pigs like this do make for some good stories. Some friends of mine and I were caving in a different part of the cave. They sat down for a break. I moseyed ahead looking at everything. Came across a pig. It looked like it had been dead maybe 2 to 3 days based on the eye. So I went back to them and I said, guys, prepare yourselves. There's a fallen caver ahead. They didn't make it.
Oh, you.
And the girl that was with us, Lynn, her first reaction was, really? What happened? They didn't make it? This was followed by, they didn't make it. Really? What happened? This is followed by a long pause. And then, they didn't make it. What happened? She just escalated. And it's improper etiquette. The other leg looks more like a pterodactyl wing. That is by far the best example of that process I've seen anywhere. And it just goes to show you that even if you're a horrible painter,
Still makes
eye
smart.
second color highlights some of the tips.
Uh-huh.
Right above me is slightly higher than the top of the falls, but there's 5 levels of cave here.
Oh, yeah. Yeah. Outside air.
Well, the air quality down there is good.
Yeah.
We have 100.
Oh, neat.
Wow, that's a big footage.
All the training is done inside and underneath.